Hey folks, today we're going to do worksheet number 4, review of unit 13. Notice this is only problems 1 through 5, 6 through 10, and then 11 through 15, etc. They're all in separate podcasts, just so it doesn't get too long. Right. So the first thing we're talking about is this true or false? The equation nitrogen plus hydrogen gives NH3. Can it be interpreted as saying 1 mole of nitrogen plus 3 moles of hydrogen give us, it's supposed to be give us, 2 NH3, 2 moles of NH3. Well, you could certainly say 1 molecule of nitrogen plus 3 molecules of hydrogen give me 2 molecules of ammonia, or a dozen molecules of nitrogen plus 3 dozen molecules of hydrogen give me 2 dozen molecules of ammonia, or 100 nitrogens plus 300 hydrogens give me 200 ammonias. So logically it would stand to reason that 1 mole of nitrogen, just like 1 dozen nitrogen molecules, plus 3 dozen or 3 moles of hydrogen would give us 2 dozen or 2 moles of ammonia. So the answer to this is definitely true. Now, is it true or false that a balanced chemical equation is one that has the same number of moles of molecules on each side? No, this is definitely not correct. Look at this equation right here. Here we have 4 moles of molecules over here. We only have 2 moles of molecules over here. So this is definitely false. Now, it's very close to being true, because if you talked about atoms, you're correct. Atoms is right. Molecules is wrong. Right? Because you do have 2 nitrogen atoms on both sides, and you have 6 hydrogen atoms on both sides. So atoms, yes. Molecules, no. All right, the mole ratio is used to convert the moles of a starting substance to moles of the desired substance. That's what stoichiometry is all about. And so that's what we do in Stoich, and that's what we're going to do in our next slide. So definitely yes, that is true. Many metals react with halogens to give metal halides. For example, iron gives iron 3 chloride on reaction with chlorine gas. So let's go ahead and write that out. That's iron plus chlorine gas gives you iron 3 chloride, FeCl3. Iron has 3 plus, chlorine has -1. Now, it does ask us to put in phase notation. Iron at room temperature is solid. Chlorine at room temperature is a gas. By the way, it told you that right here. And iron 3 chloride, if you look it up on your solubility table, is going to be aqueous. Okay. Now, beginning with 10 grams of iron, what mass of chlorine in grams is required for a complete reaction? So we start with 10 grams of 10.0 grams of iron. Now we have to use this equation up here, but it's not balanced yet. And the reason it's not balanced is because you have 2 chlorines on the left and 3 on the right. That means we have to put a 2 in front of our iron chloride and a 3 in front of our chlorine to balance it, which gives us 6 chlorines on both sides. We also need 2 in front of the iron so that we can have 2 irons on both sides. So now we can actually use this information to go and do some stoichiometry. Now we're trying to convert from grams of iron to grams of chlorine. But you can't convert from grams of iron to grams of chlorine. You have to go to moles first. So you have to go from grams to moles of your starting substance to moles of your target substance to back to grams, because that's what it's asking for. So that's what we're going to do. So we start with 10 grams of iron, and we have to convert from grams of iron to moles of iron. And then we convert from moles of iron to moles of chlorine gas, because that's what it's asking us about. It's saying what mass of chlorine gas, so that's what our target is. And then we have to go from moles of chlorine gas to grams of chlorine gas. Right. Well, now the problem is we actually have to go look some things up on the periodic table, because we have to figure out how much 1 mole of Fe weighs. Well, if you look on the periodic table, that's 55.847 grams. Now, what's our ratio of iron to chlorine gas? Well, I look up here, my ratio of iron to chlorine gas is 2 to 3. That's 2 to 3. And now I have to go from moles of chlorine gas up to grams, and notice chlorine is diatomic. Each one is 35.453, so I have to multiply them together times 2. Actually, I have to add them together and multiply them times 2 to get 70.906 grams of chlorine gas. Okay. So that will give me a total of 19.0 grams of chlorine gas. Okay. Everybody okay? Now, let's keep going. Got my balanced chemical equation up here, almost. It is balanced now. And assuming a complete reaction, what quantity of iron chloride in moles and grams can be produced? All right, so let's do this one at a time. We have to go back to our complete reaction, and again, we're starting with 10 grams of iron. All right, so that's what we're going to work with. 10 grams of iron, 10.0 grams of iron. By the way, let me just stop there. Notice that I've got 3 sig figs here. All of my answers should have 3 sig figs. Did I do that in my last one? Yep, I did. Right? So you see 3 sig figs in your problem. You should always have 3 sig figs in your answer. All right. So let's go ahead and try this. I have 10 grams of Fe, and I'm going from grams of Fe to moles of Fe. But I don't want moles of Fe. I want moles of my target, which is FeCl3. Because that's what I'm asked in the question is about FeCl3. Right. So if I do the math here, and my grams of Fe, we already know that. That's 55.847 in 1 mole. And my Fe to FeCl3, that is a 2 to 2 relationship. So the 2 and the 2 are going to cancel each other out. So this is essentially 10 over 55, which is going to give me 0.180. Again, notice 3 sig figs, moles of FeCl3. Right, now, realize that I could keep going to get grams, or I could just redo the entire problem. Now, the only problem with stopping and then starting again is that I did some rounding to come up with this answer. So now when I go to grams, I'm going to continue to round, and that's not a good thing. All right? So it often is a better choice to just start all the way back at the beginning so that you don't get any rounding error along the way. Right? So we're going to start with 10.0 grams of Fe and 55.847 grams of Fe in 1 mole of Fe. And then we want to get rid of 2 moles of Fe, going to 2 moles of FeCl3. Now, so far that's exactly what we have right above us. Right? But now the difference is we have to go to grams of FeCl3 because that's what it's asking us up here in the problem. We put 1 mole of Fe down here, and we have to go to grams of FeCl3. So we have to add 55.847 to 35.453 times 3, and the answer that we get is 162.206 grams. And when I multiply that out, I actually get 29.3 grams. All right. Now it says, what happens if only a certain amount of FeCl3 is obtained? Well, I expected 29.3 grams, but I only got 18.5 grams. When I divide those, you always put what you actually got over your expected, and you multiply by 100, and that's a percent. So that's going to give you, in this case, it's going to give you 63.1%, and that's your percent yield. Okay. All right, that's number 4. Let's go on to number 5. Number 5, we have a reaction of zinc and chlorine, and it's been used as the basis of a car battery. Right? So, let's see, zinc and chlorine are reacting. Wonder what that's supposed to do. Well, if we only have zinc, and we only have chlorine gas, what's going to happen to them? Well, that sure looks like a direct combination reaction because the only thing you have are 2 elements. So that's going to be ZnCl2. Now, what happens? Well, zinc is a solid at room temperature. It's a metal. And chlorine is a gas at room temperature. You know that. And then zinc chloride, you can look it up on your solubility table, but it is going to be aqueous. Okay. So now, what is the theoretical yield of zinc chloride if you start with 35.5 grams of zinc and you have excess chlorine? Well, that means we don't have to worry about the chlorine. We start with 35.5 grams of zinc. By the way, folks, the equation up above us is balanced already. You don't have to worry about that. So you're starting with 35.5 grams of zinc. Now, when we work this through, we have to get rid of grams of zinc. And we have to go to moles of zinc. And then we have to go from moles of zinc to moles of zinc chloride, because that is our target substance. What's the theoretical yield of zinc chloride? That's what it's asking us. And so we have to get rid of moles of zinc chloride and go to grams of zinc chloride. So I'm not going to waste your time going through all of the calculating stuff, but certainly for zinc, you just look it up on the periodic table. That's 65.39 in 1 mole. And because I'm balanced and all of my coefficients are 1s, these are both 1s in here. And the other thing I have to do is figure out the mass of zinc chloride. Well, zinc is 65.39. Each of the chlorines is 35.5. So you get a total of 136.296 grams in 1 mole. When I do that math, I come up with 74.0. You'll notice 3 sig figs in the problem. Right? 0.0 grams of zinc chloride. All right, I have one more step. It says if you only get 65.2 grams, what's the percent yield? Well, our percent yield is what we actually got, 65.2 grams, divided by 74.0 grams, which is our theoretical, or what we expected to get. We multiply by 100%, and we come up with 81% as our final answer. Sorry, that's not right. 88.1%. 88.1%. All right? So, that's it for problems 1 through 5. And if you have questions, please come see us in class. We'll be happy to help you. Okay? Have a good one. Take care.